Now let's have a look at a hashing tool available on Kali Linux with a few more features than the sum tools. rahash2 is a tool that enables the use of many cryptographic hashing algorithms from a single tool. The hashing algorithms rahash2 supports includes the ones you are most likely to use in digital forensics. rahash2 also supports a wide variety of CRC, checksum, and encodings used for unpacking and decoding all sorts of binary files. I won't be covering these algorithms, but once you take a few minutes to learn rahash2, you can try them yourself. rahash2 is actually one of many tools in the Radari2 portable reverse engineering framework. Radari2 is used to disassemble binary image files, run them on a local or remote debugger, and figure out what they do. You are likely to be interested in using Radari2 if you do advanced work with malware files, which is certainly a handy skill to have in the world of modern digital forensics. And yes, the name of the toolkit is pronounced Radare. Most people, including myself, assume and pronounce the toolkit's name as Radar, but the author of the toolkit calls it Radare2. I would expect most people to call it Radar 2. As I said, rahash2 enables the use of many cryptographic hashing algorithms from a single tool. rahash2 can hash disk files and does not use hash sets, but it does provide block hashing and the ability to hash specific areas of a file. We'll get into all that in the demo. In Kali Linux 1.1.0, Radari2 is not updated using the apt-get command. This is because Debian repositories do not update their distribution package of Radari2. In fact, the version of Radari2 available in Debian is several years old. If you want to use rahash2 tool on any distribution of Debian GNU Linux, including Kali Linux, you must update Radari2 directly from its repository on GitHub. Here's how to do that. The first thing we need to do is check the version of the installed rahash2 utility using the V flag. We see here that rahash2 0.9 is very old. To update rahash2, we need to remove the entire Radari2 toolkit on Kali, download the Radari2 source code repository from GitHub, and install the latest Radari2 package. We do these steps using a few easy commands. Make sure your Kali has an internet connection, and let's begin. First, you'll need to completely uninstall the ancient version of Radari2 installed on Kali, using the following commands. These commands will remove the Radari2 package and the Radari2 libraries from Debian GNU Linux. Next, you'll need to pick a place to keep the Radari2 repository files. I would suggest user local source to be a typical place, but it can be anywhere that you see fit. Next, use this command to download the Radari2 repository from GitHub. This may take a few minutes depending on the speed of your internet connection. In this example, the downloaded files will be stored on the subdirectory user local source Radari2. Next, build Radari2 using the following commands. The build will take a little while depending on the speed of your computer and internet connection. The Radari2 executable files will each be stored in separate subdirectories under user local source Radari2 bin r, and symbolic links to these executable files are placed in user bin. After the build is completed, run the version command again and verify that rahash2 is now the latest version. To update rahash2 again, you only need to change to the subdirectory where you have downloaded the Radari2 repository files and run the sysinstall.sh command again. The latest file updates will be automatically downloaded and built. Their code in the rahash2 tool itself may not be updated very often, but the Radari2 project is very active, and the repository receives several updates per day. So remember to update your Radari2 installation once in a while. The first thing we always check is how to find help using a tool. The H flag shows us the command line usage of rahash2, and rahash2 has a manual page as well. The simplest way to use rahash2 is by giving a file name to hash. The output is the name of the file, the range of bytes in the file that were hashed, the hashing algorithm used, and the hash value. rahash2 uses the SHA-256 algorithm by default. The A flag allows you to specify which hashing algorithms to use. The capital L flag shows a listing of all the hashing algorithms that can be specified using the A flag. For most digital forensic work, you will only need MD5, SHA-1, and SHA-256. If you want to produce multiple hash values for the same file or group of files, supply multiple A flag options separated by commas. If for some reason you want to calculate the hash and checksum value of every algorithm supported by rahash2, use the All option with the A flag. As I said, for digital forensics, MD5, SHA-1, and SHA-256 will be all you need. Of course, wildcards can be used to hash multiple files in one go. If you only want to see the hash value output and not the file names, you can specify the Q flag. The Q flag suppresses displaying the name and hashing range of each file. Notice the invalid file size error? That's from trying to hash a zero-length file. Zero-length files do have a valid hash for each hashing algorithm, but the version of rahash2 I am demoing does not support hashing zero-length input and throws an invalid file size error if you try to hash a zero-length file. If you don't want to see Linux error messages in your rahash2 output, then redirect the standard error to dev null. There you go, nice and clean. rahash2 hashes the entire input file by default. rahash2 can also perform block hashing and selective area hashing on input files too. This example block hashes a file 263,222 bytes in length, or 40,436 bytes in hexadecimal. The B flag is specifying in hexadecimal notation that the file is to be hashed using a block size of 65,536 bytes. The capital B flag indicates the file should be hashed in blocks. The size of each is indicated by the B flag, and the hash value of each block should be displayed. This output shows 5 hash values resulted and their byte ranges within the file. The last block is shorter than 65,536 bytes because the length of the file does not end evenly on a 64K boundary, and this is typical. The B flag and the capital B flag must be used together. If you only specify one or the other flag, the entire file is hashed as a single block, as if neither flag were used. Be careful not to make this mistake. One other thing to keep in mind when block hashing a file or file stream is that you may end up with multiple blocks producing the same hash value because they contain identical information. It is not unusual for files to use runs of identical byte values as padding. For example, if a large section of 0 byte values is divided into multiple blocks and hashed, each block will have the same hash value because each block is identical in content. This example shows multiple identical hash values resulting from very long contiguous runs of identical byte values. Just something to be aware of when you are looking at a listing of hash values produced by any block hashing tool. Selective area hashing is performed using the from and to flags. These flags indicate the byte offset of the first byte and the last byte in the area to hash. This example hashes one of the blocks in the previous block hashing example. The from value is 0-based, so the first byte in the file is at offset 0, and the last byte in the file is specified by the number of bytes in the file -1. Always remember 0-based offsets are used and don't get snagged by the frustrating off by 1 error. If you specify an illegal from value, or the from value is missing from the command line, 0, the beginning of the file, is used as the default from value. If you specify an illegal to value, or the to value is missing from the command line, the offset of the last byte in the file is used as the default to value. We can use this default behavior to produce a single hash value of the area from the from offset to the end of the file, and from the beginning of the file to the specific byte offset. The from and to flags can also be combined with the B and capital B flags to begin or end a block hashing from a specific byte offset within the file. This example starts block hashing at byte offset 10,000 hex. This example stops block hashing at byte offset 2FFFF hex. Note that only one selective area can be hashed per execution of rahash2. If you want to generate the hash value of multiple selective areas of a file, you will need to run rahash2 once per area. Be sure to always check the beginning and ending offset values for each hash value produced, so you are sure you really are hashing the byte ranges you want to be hashing. Now let's look at some additional useful features of rahash2. rahash2 has the ability to hash a literal string value directly from the command line. You only need the quotes if the string contains whitespace characters. If you omit the quotes, the string is only hashed to the first whitespace character. You can see in the byte range that the length of both strings is 4 bytes, and they produce the same hash value. Be careful not to make this mistake. If a string contains embedded double quotes, then enclose the string in single quotes. Okay, so what if the string you are hashing has both embedded single and double quotes? Well, the version of rahash2 that I am demoing here does not support character escaping to indicate that a single or double quote character should be interpreted literally and not as a string delimiter character. If you need to hash a string that requires character escaping, your best bet is to write the string to a file, strip the terminating line feed character if necessary, and then hash the file. Yep. All that crazy single, double quoting is necessary for writing the string to the temp file. A related feature allows rahash2 to encode and decode a base64 string or file. This feature is very useful when working with files that contain base64 encoded information, as web and email files often do. To base64 encode a string from the command line, use the D flag to indicate encoding and the S flag to specify the string. To base64 decode a string from the command line, use the capital D flag to indicate decoding and the S flag to specify a base64 encoded string. To base64 encode and decode files, just give a file name instead of the S flag and redirect the output to a file. What I did here was to encode a binary file to a base64 encoded file, recreated the binary file from the base64 encoded file, and then hashed the original and resulting binary files to show they are identical. Base64 encoding and decoding is typically performed when binary information, such as an image file, is embedded in a web page or email. Try this yourself on a binary file and see if the hash values of the before and after files match. In summary, rahash2 provides cryptographic hashing capabilities using the MD5 and SHA hashing algorithms. rahash2 can be used to check the identity and verify the integrity of files, and both block hash and selective area hash files. rahash2 can also hash character strings on the command line and base64 encode and decode information. rahash2 does not create or use hash sets and must be downloaded from GitHub and built to update.